Given question, draw shear force diagram and bending moment diagram. Find the location of point where shear force is 0. Also find the value of maximum bending moment. To draw the shear force and bending moment diagram, first step is to draw the free body diagram. This is the question of simply supported beam. So we have to show the reactions at the supports, that is at point A and at point B in vertically upward direction. So here is RA and here is RB. Now if we observe the diagram, then for uniformly varying load, total load is mentioned and that is equal to 30 kilonewton. Now we have to find out the point of application of load, or it is also known as center of gravity point. So first we will observe here is the maximum load. So at point D maximum load is given and at point C load is 0. Now point of application of load we have to show here in between the span CD, and we have to make the two parts. So one part is from the point of this maximum load and it is equal to 1 by 3 multiplied by the total span. So total span is given 3 meter. So here from this point D we will mention 1 by 3 multiplied by 3, and from the minimum load or zero load this is 2 by 3 multiplied by the total span 3, that is 2 by 3 multiplied by 3. So in between this CD we have to show this, and here is the point of application of load, and this load is equal to 30 kilonewton in vertically downward direction. So we will show here. So in short, if we simplify this, 1 by 3 multiplied by 3, that is equal to 1 meter. So I will directly write here 1 meter, and here 2 by 3 multiplied by 3, that means this is 2 meter. Now second step is to find out the unknown forces. So if we observe in this diagram, RA and RB are the two unknown terms. So we have to find out. So how to find out? For that we will consider the system is in equilibrium. So when the system is in equilibrium, then we can say that summation of all vertical forces is equal to 0. Summation of all horizontal forces is equal to 0. Summation of moments of all the forces about any point is equal to 0. So when we apply summation of all vertical forces is equal to 0. So how we can write? So this RA, RB in upward direction and this 30 kilonewton and 15 kilonewton in downward direction. So we can say that RA plus RB is equal to 30 plus 15, that is equal to 45 kilonewton. Now we will move to the next. So there is no any horizontal force. So we will move summation of moments of all the forces about any point. So there are two unknown points, RA and RB, both are unknown. So we will consider any one point. So I will take here summation of moment of all the forces about point A is equal to 0. Now we will solve this. So for that direction is important. So for clockwise moment we will consider positive sign, and for anti-clockwise we will consider negative sign. Now we have to take the moment about A. So first is 30 kilonewton. If I move the compass about A in this 30 kilonewton, then it is in the clockwise direction. So we will take 30 multiplied by distance in between A and this 30. So it is 1 plus 2, that is 3. Then next 15. So if I move the compass about A in the direction of 15, then it is also in clockwise direction. So plus 15 multiplied by distance in between A and this 15 kilonewton. So 3 plus 1, that is 5. Then next is RB. So if I move the compass in the direction of RB, then it is anti-clockwise direction. So minus RB multiplied by distance in between A and B. So 3 plus 1, 4, 5, 6. RB multiplied by 6 is equal to 0. So we will solve this. 90 plus 75 minus, so I will transfer this 6 RB, and therefore we can find this RB, and from the value of RB we can also calculate RA. Next step is to calculate shear force. So it is the summation of forces either on the left hand side or on the right hand side. In this question we will take the summation of forces which are on the left hand side of the selected section. So we will follow this sign convention. So on the left hand side, if the direction of force is in the upward direction, we will use the positive sign, and if this direction is downward, then we will use the negative sign. Now we will consider the section AC. So I will show here the section line. Now if we observe the left hand side, then there is the one force RA which is in the upward direction. So according to the sign convention, this sign will be positive. So we will write for section AC, shear force is equal to plus 17.5 kilonewton. Now we will move to the next section, that is section CD. Now for this section CD, I will show here the section line. So I will draw one section line. Now if we observe the left hand side, then there are two forces. One is in the upward direction and other is in the downward direction. So for downward direction we will use the negative sign. So it is equal to plus 17.5 minus 30. So we have to calculate this, that is minus 30 plus 17.5, that is equal to minus 12.5 kilonewton. Now we will move to the next section, that is section D to E. Now if we observe in between this D to E, if I show here the section line, then the same two forces are there, that is plus 17.5 and minus 30, which are on the left hand side. So here I will show the same load, that is minus 12.5 kilonewton. Now we will move to the next, that is the section EB. So I will show here the section line in between E and B. Now if we observe how many loads are there, so here this is in vertically upward direction. So we will take plus 17.5, then here minus 30 and here minus 15. So minus 12.5 we have calculated for this, minus 15, that is equal to minus 27.5 kilonewton. Now this shear force data is available, so we will draw the shear force diagram. So we have to first show one baseline, and we have to plot the positive values in upward direction. So for the section AC it is plus 17.5, so I will plot here 17.5. Then next for CD it is minus 12.5 kilonewton, so I will plot here the value 12.5. So because of this minus sign we will plot below the baseline. Then next is also minus 12.5, so here in between section DE same value is minus 12.5, and then for EB it is minus 27.5 kilonewton. So no need to show here negative sign because we have to plot this in the downward direction. So next magnitude we will plot 27.5 kilonewton. Now we have to draw the shear force diagram. So we have to observe in between section AC there is only point load. So for point load we have to show shear force with constant line. So in between section AC I will draw here one constant line. Now in between section CD uniformly varying load is given. So for uniformly varying load we have to show this with parabolic curve. So I will show in between this section C to D. So this value at point C is 17.5. So it is varying from plus 17.5 to minus 12.5, and it will cross this baseline. So I will show the parabolic curve. This is the parabolic curve. Now we will move to the section DE. Now if we observe in between section D at point E there is point load. So again we have to show with constant line. Now at point E this load varies from minus 12.5 to minus 27.5. So again we have to draw one vertical line at point E. So I will show here, I will extend this line, and then for section EB I will again show the constant line. Now we will complete this diagram. If we observe the shear force diagram, here is the point where the shear force value is equal to 0, and we have to find out the location of this point. Now this curve is the parabolic curve. So I will extend this line in the upward direction. And this distance of this point of application from the point C we will consider as a distance x. To find out this distance x where shear force is equal to 0, we have to first calculate the formula to find out shear force at any distance x. So I will show here one vertical section xx. So how to find out the shear force at the distance at this section xx? Now we know that for uniformly varying load, total load is given 30 kN, but the rate of loading at this maximum load, that is at point D, is not mentioned in the question. So how to calculate this? So I will mention here the new point. This point will be P. Now at a section xx I will mention here this new point, that will be Q, and here this point will be R. Now with reference to this diagram we will first find out the rate of loading at point D. So how to find out? So for uniformly varying load we know that this total load is equal to area of triangle CDP. So I will write here area of triangle CDP is equal to 30 kilonewton. So how to write this area of triangle? That is half multiplied by base. So base is CD and that is equal to 3 multiplied by height. So height is DP, which is equal to 30 kilonewton. So DP is equal to, if we simplify this, so 30 multiplied by 2, 60 divided by 3, that is 20 kilonewton per meter. So this is the rate of loading at point D. Now in the same way we have to find out rate of loading along the section XX, that is along the section this RQ. So how to find out? Now if we observe there are two similar triangles. So here is from triangle CDP and triangle CQR. We will take the ratio base to the height. So I will take ratio CD divided by DP is equal to CQ divided by QR. Therefore, now we will put the value. So CD is equal to 3 divided by DP. So DP we have calculated 20 is equal to CQ. So CQ is this distance x divided by QR. Now we have to find out this QR. Therefore, QR is equal to, so if we calculate this we will get 20x by 3 kilonewton per meter. So this is the rate of loading. So we have to show here this rate of loading 20x by 3. Now we will plot the rate of loading along the section XX, that is equal to 20x by 3, and the rate of loading at the maximum load D is 20 kilonewton per meter. Now we have to draw the free body diagram to find out the shear force at any distance x. So how to draw this? So for that we have to first calculate the total load. So we have to find out the total load in between this CQ. So how to calculate this? So we know that total load is equal to area of triangle. So I will write here total load is equal to area of triangle CQR. CQR, and that is equal to half multiplied by base. So base is CQ, that is x multiplied by height. So height is RQ, and value of RQ is 20x by 3. 20x by 3. So we will simplify this. So it will get 2 and here is 10. So 10x square by 3. So this is the total load. Now we will draw the free body diagram. So we will consider the section from point A to Q. So here is A. We have to show at point A reaction 17.5 in upward direction. Now next is in between CQ. So distance CQ is x. Now we have to show point of application of this force. So we know that this point of application of the force or center of gravity, we have to take the two parts, that is 1 by 3 multiplied by this total span and 2 by 3 multiplied by this total span. So this 1 by 3 multiplied by this x is from the maximum load. So maximum load is along this RQ, that is from this point Q. So I will divide this part in 1 by 3 multiplied by x, and the remaining will be 2 by 3 multiplied by x, and we will show this. Now this is the point of application of load. So we will show this point of application of load, and this load is equal to 10x square by 3. Now we will calculate the shear force at any distance x. So if I show here one section line at a distance x, that is here is the section line, then how to show this shear force? So we will take the summation of forces which are on the left hand side. So according to the sign convention, so I will write here SF at a distance x, that is SFX is equal to. So the forces which are on the upward direction, which are in the upward direction and on right hand side, we will take plus 17.5, and forces which are in downward direction, we will take the negative sign, that is minus 10x square by 3. This is the formula we get to calculate shear force at any distance x. So to find out the distance x where the value of shear force is equal to 0, we have to show this formula is equal to 0. Then we can calculate the value of x. So we will simplify this. We will transfer this negative term to the right hand side. So we will get 10x square by 3 is equal to 17.5, and therefore 10x square is equal to 52.5, and therefore x is equal to 2.29 meter. So this is the distance x, that is the distance in between C and Q where the shear force is equal to 0. So we will plot this value 2.29 meter in shear force diagram. Next step is to calculate bending moment. It is the summation of moment of all the forces either on the left hand side or on the right hand side. In this question, we will take the summation of moment of forces which are on the left hand side. If we observe the sign convention, if the direction of moment is in clockwise direction on left hand side, then we will use positive sign, and if this direction is anti-clockwise direction, then we will consider the negative sign. Now we will take the bending moment about point A. If we observe, there is no any force on left hand side at point A. So we will take this moment is equal to 0. Now next is bending moment about point C. Now if we take the center as a C and move the compass in the direction of this 17.5 kilonewton, that is in the upward direction, then we will get the clockwise direction. So moment is plus 17.5 multiplied by 1. Now next point is D. So how to calculate bending moment about point D? So here this is in clockwise direction and this 30 kilonewton is in anti-clockwise direction. So we will take plus 17.5 multiplied by distance in between AD, that is equal to 4, minus, because if I move the compass in downward direction then it is anti-clockwise direction, so minus 30 multiplied by distance in between 30 kilonewton and D, it is 1. Now next is bending moment about point E. So again plus 17.5 multiplied by distance in between AE, that is 3 plus 4 plus 1, that is 5. Then minus 30 multiplied by distance in between this 30 kilonewton and this point E. So it is 1 plus 1, that is 2. Now next bending moment about point B. So again I will take 17.5 multiplied by total distance is 3 plus 1 plus 1 plus 1, that is 3, 4, 5, 6. Then minus 30 multiplied by distance 1 plus 1 plus 1, that is 3. Then minus 15 multiplied by the distance in between EP, that is equal to 1. To draw the bending moment diagram, we have to first show the baseline. Now if we observe the calculations, all the values are positive and we have to plot these values in the upward direction of this baseline. So at point A, value is 0. So I will plot here this 0. Then at point C, the value is plus 17.5. So I will plot here 17.5 kilonewton meter. Then at point D, it is 40 kilonewton meter. So I will plot here 40 kilonewton meter. At point E, it is 27.5. So at point E, I will plot here 27.5 kilonewton meter. And at point B, value is 0. So I will plot here 0. But if we observe at point Q, shear force is equal to 0. And when shear force is equal to 0, then at that point there is maximum bending moment. So we have to first find out the bending moment at point Q. To find out bending moment at point Q, we will draw the free body diagram from this point A up to the point Q. So we will show here the force at point A, that is equal to 17.5 kilonewton in upward direction. Then the distance in between C and Q is equal to X. Now we have to find out the total load that is acting in between this CQ, that is over the span of X. So how to calculate this? So we know that this total load is equal to area of triangle CQR. So we will calculate here total load is equal to area of triangle CQR, and that is equal to half multiplied by base. So base is X multiplied by height. So height, if we observe RQ, the rate of loading is given 20x by 3. 20x by 3. Now we will simplify this. So we will get 10x square by 3. So this is the total load. Now where is the point of application of load? So it is in between CQ. So point Q is where the maximum load is applied. So from this maximum load, we have to take total distance divided by 3, that is 1 by 3 multiplied by this total span. And from this minimum load, that is from this point C, we have to take 2 by 3 multiplied by X. So I will take here X by 3 and here 2 by 3 multiplied by X. So we will show here the point of application of load or center of gravity point, and this load is equal to 10x square by 3. Now from this diagram we will calculate bending moment at a distance x. So how to calculate this? So we will take the summation of moment of forces which are on the left hand side. Now if I move the compass about point Q in the direction of A, then we will get the clockwise direction. So we will take positive sign, that is plus 17.5 multiplied by the distance. So distance is 1 plus x. Then we will move to the second load. So it is 10x square by 3. So it is in anti-clockwise direction. So we will take minus sign. So minus 10x square by 3 multiplied by the distance in between this point of application of load and Q, it is x by 3 multiplied by x by 3. Now we will simplify this. So here it will become 17.5 plus. Now if I calculate inside the bracket, then 17.5 multiplied by x. But value of x is 2.29 meters. So we will calculate here 17.5 multiplied by 2.29. That is 40.07. Now we will simplify this minus 10 x cube by 9. 10 by 9 multiplied by x cube. So x cube, that means 2.29 cube. So I will calculate here 2.29 cube, that is 12. So we will again calculate this. So we will get 40.07 plus 17.5, that is 57.57 minus 120 divided by 9, that is 13.13. So if we calculate this, 44.23. So this is the bending moment at point Q, where this maximum bending moment, because at this point shear force is 0. So we will plot this. Now we will complete this bending moment diagram. If we observe the section AC, then in between this AC point load is there. So bending moment will vary linearly. So we have to show the linear line. Now if we observe the section C to D, so section C to D is having uniformly varying load. So we have to draw the cubic curve, because it will, that is the bending moment will vary from this point C to point D with cubic curve. So we will draw here the cubic curve to join all these points. Then for section DE, again point load is there, so we have to show the linear line. And then for the next section EB, again we have to show the linear line.